Today we will discover that the intersection of two curves can provide us with a means to solve equations that otherwise could not have been solved. And to understand why this is so, let's first consider the equation y equals x plus 2. Can this equation be solved? And the answer is of course not, because this equation on its own has an infinity of solutions. When x is 1, y is 3. When x is 2, y is 4. When x is 10, y is 12, and so on. So there is an infinite set of solutions for this particular equation. And the same applies for another equation, y equals 8 minus 2x. This equation alone as well has an infinite set of solutions. However, in this case, there is one particular solution that is common to the two equations. And that is what we learned before as the simultaneous solution. In this case, because y is equal to this function of x and y is equal to this function of x, that is, y is the subject in both cases, solving simultaneously gives us x plus 2 equals 8 minus 2x. Thus, 3x equals 6 and x is equal to 2. And then you take this value of x and substitute in any of those two equations to find the value of y. And because this equation looks simpler, I would simply find that y is equal to 2 plus 2, which is 4. So your solution is 2, 4. Note that it is written as an ordered pair with x and y. Now this is the algebraic argument. If we are to consider the graphical argument, then we can consider the line x equals 2, y equals x plus 2. It's this line with a slope of 1 and a y-intercept of 2. This line is made up of an infinity of points. Each of the points represents a particular solution for that equation of the line. And if we look at the other line, 8 minus 2x, again, here we have another line. In its own right, it's made up of an infinity of points as well, each representing one of the possible solutions for that equation. But there is one point that is common between the two. That is the point that lies on both lines, which is the point with coordinates 2, 4. And that is the simultaneous solution. That is the common value of x and y that satisfies both equations. It's the point that lies on both lines. So this tells us that we can find solutions of equations. For example, if we have a strange equation like 2 to the x equals 0.5x plus 2, and I want to solve this. Now, if I want to solve this, I have no algebraic means to do that, because this is 2 to the power x and this is 0.5 times x, and there is no algebraic way to solve it. So what I can do is use technology and draw. I can consider f of x to be 2 to the power x and g of x to be 0.5x plus 2. And I can draw. And the point of intersection of the two curves will be the solution. So let's look at that. Let's hide these. And let's first of all draw 0.5x plus 2. This is a straight line. Slope is 0.5 and the y-intercept is 2. If we draw f of x equals 2 to the x, this is what we get. Let's move it around a little bit so that we can see. And we have 2 points of intersection. And if you look at them closely enough, it looks that they're not exact. But what we can do is use technology to help us locate the coordinates. Let's snap to the intersection, and if we press here, it tells us that one of the solutions is x is 1.44 approximately. And if we click here, we find that the solution is negative 3.86. So x is approximately 1.44 or negative 3.86. And note that because we started with something of the form f of x equals g of x, i.e. an expression in x equals to another expression in x, my solution would simply require me to list the values of x where the left hand side is equal to the right hand side, which is the 1.44 approximately and the negative 3.86. There is no need for the y coordinate. However, if I was asked to solve simultaneously y is equal to 2 to the x and y is equal to 0.5x plus 2, then I do have a y in the problem, and the simultaneous solution should include an x and a y. So in this case, I will go to the graph, and let's snap here, and we have the 1.44, and y is 2.72. So the first solution will be and the other solution will be the coordinates of the point of intersection. In this case, it's negative 3.86 and 0.0687. And 0.0687. And those would be the two simultaneous solutions of those two equations.